Okay, so here we're looking at the fractional exponents module in Khan Academy. We're given these fractional exponents, positive and negative, where the numerator and denominator form a process that helps you break down these expressions into answers. So these bases right here might be fractions or whole numbers, and these exponents right here could be positive or negative. It could be an improper fraction or a simple fraction, but either way, we can break this thing in pieces to solve it. So if we look at what this is saying, we're taking 16/25 and raising it to the negative 3/2. What does that mean? Well, to understand what this means, you have to realize that you can take 16/25 and split this power apart. Negative 3 times 1/2 is equal to what? Well, negative 3 times 1/2 is negative 3/2. So we haven't changed anything here. We're just writing the exponent in pieces. And negative 3, well, that could be thought of as what? Well, negative 3 is negative 1 times 3 times 1/2. So what I've done is I've kind of exploded this exponent into its pieces because these pieces are commutative. They're being multiplied, so I can apply any part of this exponent when I want, or at any time that I want. So here, what I might do first is apply the negative exponent, right, negative 1. With a fraction, when you have it to the negative power, you flip it upside down because you're taking 1 divided by this base. So 1 divided by 16/25. That's what that means, right? And dividing by a fraction, you multiply by the reciprocal. So we're going to get 25/16. So we flip the base. And then we have still 3 times 1/2. Well, the 1/2 means square root. I'm going to apply that one next because I don't want to raise 25 and 16 to the third power. It's a kind of annoying, right? So instead, I take the square root of 25, that's the half power, and I get 5. And the half power of 16 is 4. And this is still raised to the third power, but this is more manageable. Here, when this fraction is raised to the third power, right, this is all in parentheses, sorry. Should be in parentheses. If it wasn't in parentheses, that would just imply that the numerator is being raised to the power, but really the whole fraction is being raised. So 5 to the third is 125, 5 times 5 times 5, and 4 to the third is 64, and that would be our answer. Now, just to recap what we did, we break apart the exponent into a way that's friendly to us, and apply any part of the exponent in any order that we want, and we'll end up with this answer. As a similar example, going back, we had 16/25. What if I, instead of applying the negative 1 first, what if I applied the square root first, right? And then the third power, then the negative 1. Will I still get the same answer? Well, I said it was commutative, so we should, but let's just check. The square root of this fraction is 4/5, right? And we're still raising it to the third times negative 1 power. Okay, I'll write like this, negative 1. And the third power, we get 64/125, and we still have to apply the negative 1. This fraction to the negative 1 power would get you 125/64, the same answer. So when you're given these, break them apart in pieces. You don't have to actually physically write it out. As you get better at this, you'll see these kind of exponents, right? When I see negative 3/2, I know, oh, the negative means I flip the fraction. This 2 in the denominator means square root, and 3 in the numerator means third power. So if you're given these fractional exponents, I'll write this out over here, and you see the negative, that means flip it. If you see a number up here in the numerator, that's your power you're raising it to. And down here, this 2, you're raising it to the half power, but that's really the root that you're looking at. So this is the root. You can think of it as the power up here. And here, are you taking the reciprocal of your fraction? Well, if it's negative, you are. If it was positive, you would not flip it. The power up here, you're raising it to the third power, fourth power, whatever. If you can take the root first down here, because a half or a third root or a fourth root, those exponents, half, third, and fourth, really mean find the roots, the square root, the third root, the fourth root. That will reduce your fraction before you have to raise it to your power. So I always try and see if I am flipping it. Then I look, am I taking a root? And then I apply the power up here. All right, thanks.